That sounds great. Thank you, and thank you for that nice introduction. Um, like was just mentioned, my name is Russell, and I'll add to my intro by saying I am not a physicist. I'm not a quantum researcher. In fact, by trade, I'm a designer. It's kind of a slightly different place, but I've been lucky enough to work in quantum computing since 2018, so just about 5 years. And my primary focus is on education. And really, what that means is that we believe and hope that quantum computing will be accessible to everyone eventually, right? We hope to basically bring this out of the lab and into the world. So I'm not a physicist, I'm not a researcher, and if I do my job right, then hopefully other people will be able to get into quantum computing who are also not physicists or researchers. So that's kind of my anti-introduction. But anyway, I'm very happy to be here, and I'm going to be talking today about this about how to use quantum computing for as a part of like an artistic practice. I call it the affordances of quantum art. And so this image over here on the right, that's a picture of me as drawn by a quantum computer. So this is, I don't know, maybe the first self-portrait done by a quantum computer. It'd be kind of a cool, neat thing if I could prove that that's true. But this is all tied together, right? I think there's a general idea here where, as a technology matures, realistically speaking, we need to get creative people in and start using this tech. It's not something that should stay in the realm of the labs, and it's not something that should stay just in the hands of the researchers. And so, as the tech continues to mature, I hope to see more and more artists. And so, what this talk will be today, it's going to be a kind of a short one, hopefully, kind of a fun one. It's really the seed of an idea. It's the idea of why quantum computing actually makes sense from an artistic perspective, and basically like why we should start doing it. I'll try and plant that seed with with some concepts I'll show here in the following slides, and then I'm just going to show a bunch of examples of work, both either done by me or with collaboration, or just like other artists that I've discovered. It's a startlingly small group, as I think one could expect, but it's growing, and I find that very, very exciting. So without further ado, let's jump into the affordances of quantum art. Um, and this is where I like to start with a relatively simple statement that every technology and every artistic medium has a set of affordances that make them unique. And even like a slightly different way to say that is that really technology and artistic mediums are the same thing. It really just depends on how we are exploiting those technologies. So I'll give I have a smattering of examples here. I think the most tangible one is photography. Photography as a medium is under 200 years old. And when it first came out, it was very, very much so a technical practice. It was chemistry. It was photosensitive emulsions, and it was very much so a technical process, and it took some time before it really became this creative practice. And really the primary affordance of photography is like the ability to capture a moment in time. This is the most authentic capturing of moments in time, at least when it was first coming out. And it sounds funny, but that's not actually originally how photography was used, but we eventually came to figure out what those affordances were. And you can take that exact same philosophy and you can apply it to basically any technology. So for this to the right, for example, the affordances of digital media is a little bit different. It allows people to be able to interact with artworks in a way that they hadn't before. The affordances of watercolor, there's an expressive quality, and so it's actually pretty rare to be towards the beginning of a new medium, right? Like the gap between like inventing of photography and whatever medium came before that was possibly hundreds of years. I don't actually know what that would be, but as the life cycle of technology speeds up, it's actually still a very cool thing to be able to be at the beginning of a new medium. And if you can kind of guess where I'm going with this, I would argue that a quantum computer does exactly that. So it's like we're at the beginning of a new technology with new creative opportunities. And that's to say, quantum computing is basically fundamentally starting over and inventing a computer again from scratch, right? These things are powered by quantum mechanical properties. The way we do computations is totally different. We're hoping they'll be able to solve new different problems, some new problems in a very new and different way. um but we can take that exact same philosophy and say that, like, okay, we have a net new type of technology, a net new type of computer, that then what are the affordances that I could possibly exploit as a creative person? And to me, that's like the exciting thing that we're like starting to see the very beginnings of the exploration. And you can actually take that and say that it's like we're functionally defining a new medium, that there is a new medium of art that comes with any set of affordances by a new technology. And I personally, as an artist, find this to be a very, very exciting proposition, that we're at the beginning of something new and we're trying to figure out how to use this device in creative ways. One might even say, like, what does it look like? What like it? I think I'll go back a couple sides and say that it's pretty fairly easy to distinctively say that there are different aesthetics and different styles for the various types of mediums, and we totally don't have that yet for quantum computing because we're at the very beginning of this definition, and I find that to be a particularly exciting uh, like opportunity here. I'm getting a little ahead of myself, but let's go back and say what are the affordances of a quantum computing, and some of them are kind of obvious, and it's the same things that make quantum computing like an exciting piece of tech in general. And so the first three are kind of the standard ones that get talked about in technical talks as well. So we have superposition, we have entanglement, we have interference. These are the properties that we're trying to exploit to perform computations and solve really big hard problems. Those are also the same things that we should be looking into when thinking about integrating this into a creative practice. Now, number four, I add because it's a little bit different, right? Noise is generally considered a detractor from performing good computations. Like we're trying to get noise out of our systems, out of our quantum systems. But as an artistic practice, I don't think that's the case. I think there's an opportunity here to like use the noise to make something beautiful and new and different. Um, and that last one also possibly puts us in kind of an interesting point in time where like maybe someday our quantum computers will have no noise once we actually get the proper fault tolerant systems that will be gone. So maybe that's, I don't know, 10 years from now, and we've had our current era of quantum computing, we've had these for maybe 5 years. So maybe the way that we can create art is actually like a very time boxed thing. So I find even that exciting. So I think noise is something that's worth trying to exploit and to think about a bit more. There are actually more than these four. I'll come back to them at the very end. These to me are the most like salient opportunities, but we'll come back around. There's actually quite a bit of quantum mechanical phenomena that we can start thinking about as like being something we can apply to creative practices. But we'll keep these four in mind. And for now, I'm going to switch to showing some examples of artworks that have been made that I hope maybe will serve as some inspiration for anyone out here who is hoping to try to integrate quantum computing into their own like version of creative practices. So I'll show some of my work. I'll then show some work from other folks, and we'll go from there. But so this very first one, so this is an installation that is currently up in Manhattan, in New York City, in an IBM office. That is basically a visualization of quantum teleportation, which is something that was invented by a fellow IBMer, and that we made a video about it. I'll totally share it. But as far as I know, I think this is probably the first like public installation of art made by quantum computing. So for that, I find it fairly exciting. And we'll go through kind of a couple more. So there's a fellow physicist who used to be an IBMer that I worked with named Paul Kassebaum, and we were working on a series of basically like mathematically accurate representations of qubits, but the general idea is like when we generally think about visualization, the goal is for it to be like readable and legible and can be integrated into bodies of research. And I definitely think that this type of visualization is not valuable for that. But that's kind of the nice thing about putting an aesthetic perspective on it, is we can create things that even that are the primary purpose is to be like a beautiful object, and if it's mathematically accurate, then all that much better. So I think had we not put that lens on it, we probably wouldn't have arrived at these like sculptural objects that are still faithful to the math, but aren't but with the primary purposes of being an aesthetic object. I'll go to the next one. So this is similar to the image I showed on the very cover slide, but there's a body of research around quantum image processing, and it's really, I think, in a lot of ways, an important concept. It's like if you have a computer, that the idea of representing an image with a computer shouldn't come as terribly surprising. We eventually had to do that with classical computing as well. But the primary problem with a lot of the research in quantum image processing is that it was not on near-term hardware. And this technique that I came up with does work on near-term hardware. So it takes it takes qubits and it can map them to pixel values, and then render images with it. And to me, I really like. I went through and I did a series of basically like all of the people, or at least some of the folks that made quantum computing possible, and rendered a portrait using a quantum computer. And I hope someday, kind of like in that photography example, we'll be able to look back at these like grainy, kind of nasty looking, almost Xeroxy images, and realize that it's like this was the start of what became a much like more robust field of quantum image processing. But that said, I don't necessarily think that that's like an inhibitor from making interesting works today. And so I've done a handful of installations in the same style, because I think the idea of doing quantum image processing really is ideally a foundational piece of using quantum computing as like as an artistic practice. So here's just kind of a couple more examples. I'll show a different piece of work now that kind of has two different implementations. But one of the ways that I ultimately went around learning quantum computing was basically sitting down and working my way through some of the like most seminal algorithms and just seeing if there's a way to apply it to something artistic. And so this one started by basically walking through the Bernstein-Vazirani algorithm. I figured out a way of basically ingesting text, making a text oracle for the algorithm, and then I could render that in various different ways. And so the first thing that came to my mind was doing something like the Joy Division album cover, and thus I have called it the Joy Vazirani. This link here, I actually made a web app out of it, so you can play with it, put your own text in, see what it generates. But I think one thing to note here is one of the primary ideas behind using quantum computing as an aesthetic practice is it's mostly about data interpretation. So the data that came out of this image that I'm showing here is the same data that came out of this one. So and that's to say that like it was all about ingesting text, and the way that I choose to render that data was a part of what was a part of like the actual art of it. So in this case, I decided to do a typographic piece where every letter of the alphabet, I rendered out the quantum state that came from that original input to the Bernstein-Vazirani algorithm. Um, but that's to say that step one was this quantum algorithm. Step two was to take the data source, and then the step three was to decide what I wanted to do with it uh, uh, from like a creative perspective. So. Let's talk a little bit about other artists, because I'm starting to see these. I'm starting to see quantum computing pop up in various aspects in just like different places. So this is an AI artist that I know who is starting to incorporate quantum computing into his work. And obviously, AI art is something that's very, very controversial right now. But I think there's like some legitimacy to it, and the idea of playing with different versions of emerging technologies is actually a fairly compelling one, because I think quantum computing in and of itself will have a hard time standing by itself. I mean, that's true even for just like the standard narrative quantum computing, but around aesthetics as well. I think painting and among other things, it will kind of have to coexist. So starting to see that, and I think that's kind of cool. For this one that I'm going to show, this person, Victor Mason, figured out a way to basically take the mathematics behind fractals, and there's very much like a symmetry to encoding them into quantum circuits. And they were able to, in partnership with these other two, Kate Marshall and David Marquende. I'm sorry, David, you're great. I might have mispronounced your last name. But anyway, the idea of being able to uh, like procedurally generate different types of fractals, it's actually because you're giving up some of the control, some of your aesthetic control to the quantum circuit. There's actually a pretty huge variety of stuff that can come out. And so these are just kind of like a smattering of examples, but the different circuits are going to produce different artworks, and I think that's kind of cool. This next one I'm going to show is from an artist named Roman Lipsky, who is based in Berlin, I believe, and he has worked heavily with IBM research, including one of the prior speakers today, James Wooten, with this thing called quantum blurring. And as far as I know, he had the first solo exhibition that uses quantum technologies, which is, I think, super cool. And so you can see just a smattering of examples from that exhibition space. And then the last one that I'll show is from a partnership that I've had with the New School in New York City, who has the Parsons School of Design, an art department. Like, they're called the New School. They're actually over 100 years old, so it's really kind of an old group who has generated some of the best artists of the 20th century have come out of this program, and a lot of that is due to their commitment to working with new medias and new technologies. And so I've been working with them on this exact hypothesis of what happens when quantum computing gets used by artistic people of different backgrounds. And so I've now for the past couple of years done an event with them where basically spend a week or two and have the students just kind of get like a very gentle primer to quantum computing, and then just see what they can do with it. And so we had fashion students, we had students write games, we had animations, all sorts of different things. And I think the thing that I ended up ultimately learning from it the most is that there is a like very deep, diverse amount of approaches to taking quantum computing. In fact, my general guess is that quantum computing will become a part of the process, right? It'll be a part of like somewhere, I don't know where in the pipe, where it's like I do generally dream that we'll eventually have a quantum aesthetic, but maybe it'll be more about like it'll be a part of the pre-processing, or it'll be somewhere deeper in there. Um, or just for now, maybe we just don't know yet. Maybe it's just the fact that there's a million different ways to use quantum computing, and we're still figuring out like what the actual best way is to do it. But it's been very exciting seeing actually now kind of a couple hundred students with a non-quantum background trying to use quantum computing. This is a quick example of year 2 from working with them. We worked a lot more with Touch Designer. Actually, we partnered with Touch Designer, and did a lot more like interactive installations. So I'm getting towards the end here. I had mentioned up front that it was like there's kind of these 4 affordances that I think are the primary ones, but that realistically isn't it. There's actually a lot of different properties that can be exploited possibly. And so this is a list that I came up with. Well, really, it was actually in partnership with a physicist, so I can't even really take credit for it. But in general, I think there's actually a lot of like untapped space, right? Where there's people who are starting to think about this, kind of as shown in the prior slides. But there's a lot. I don't know if anyone has specifically looked at the idea of the like what would be undetectability of sharpness, right? Like what does that mean from an aesthetic perspective? Don't actually know. And to me, that's exciting. There's actually a lot of different things that you can still do, and I think we'll be seeing them in the very near future. And so here at the tail end, I had just a couple of resources for anyone who wants them. I suspect a lot of the folks in the audience are already familiar with these things, but just had to put them just in case. And that is it. And I guess kind of the message here at the tail end is, I don't know, what are you going to make with it? Like, I really think there's a lot of potential there. So um, I am now happy to answer any and all questions that that may come up.
Thank you so much. And I also like to see that you ask a question for the audience. So, audience here, you have the chance to ask questions, but also maybe give an answer to Russell. Like, what will you make? What is your version of quantum art that you will make? Um, I liked all of them. Honestly, I was continuously trying to pick my favorite, but every new one felt like my new favorite. So I will say that the last one, the one from the jam, was my favorite just because it was the last one that you presented. um, maybe everybody else, you can also say in the chat which was your favorite form of quantum art of the ones that Russell presented today. Of course, this is not an exhausted list. You can make your own quantum art in many different ways, and this should be an invitation to be creative and think of new mediums, new ways that you can do quantum art. So remember that we're gonna have a giveaway at the end after the questions. So keep asking. If you ask a question, if you have asked a question recently, your name will be drawn for the giveaway. So now my question for Russell. Well, first, thank you, great talk, and I want to know more about maybe the origin of your fascination for quantum and art. Like as a person, what was your pathway into this like intersection?
Totally. Yeah. So, um, in a lot of ways, I feel pretty lucky to be in my position that I am, where I am by trade a product designer, a software product designer. And when I joined the quantum team at IBM, it was actually kind of a value prop to not necessarily have like a deep domain knowledge, because that meant that I could better represent my users. But the deeper I got into working around education, the clearer it became that I was like, I really, really want to have some domain knowledge. And so now I've basically spent the last 5 years trying to actually learn quantum computing. But the way that quantum computing is generally taught really didn't match my background as a designer and as an artist. And so I would read through the textbook, I would read through the material, and after reading each thing, I'd be like, okay, well, what can I make with it? Like, how can I somehow work this into the way that I think and the way that I work? Um, and so I would read a technical concept, I would try and make an art piece about it, and then I would write about it and post it online and open source the code or whatever. And then it just like slowly but surely a body of work built up and came about this idea of like, I think this idea of affordances is like a pretty good starting point for other folks too. Because I think there's legitimacy here to create a new medium. And I kind of stumbled into that. Like, really, I just wanted to learn how to do quantum computing. But I think what I ultimately end up finding is that nobody's doing this. Or I mean, there are people now, and I can't claim to be the first, but um, I but there's just like so much opportunity here as a creative person, and that was very exciting for me.
That's true. That's true. If you're coming from a different angle, uh, sometimes you can feel like you're the only person doing it, but there are
Mhm,
other people trying it out. So James Wood is an example of someone that you mentioned earlier.
mhm,
Um, but there are many other people trying out different versions of it. Um,
mhm.
I also have a question about your patents. You mentioned you're an inventor. I don't know if you can share something about this process of patenting these visualizations.
Yeah. So the reason I guess for my interest in this is like just existentially it's kind of weird to be a designer in this field, and I have found that I feel like one of the ways that I can make actual meaningful contributions is to start thinking about it from like a visualization and intellectual property perspective. Basically the idea that one of the things that I can do is I can draw, right? Where this idea of like there's a lot of concepts that have a lot of mathematics behind them, but visualizing them is something that's kind of net new, and so it's something that at IBM is encouraged to think about intellectual property, and I hope that like because really a patent is a form of a publication, in a lot of ways I hope that these will can be treated like my equivalent of a research paper or something. So um, I think that's why I've been interested in them.
Yeah, I think even more than just a research paper, you can think of it like you have created something valuable, and a patent basically shows that a little bit of that value. Of course, open source is also super valuable, and you mentioned you also contribute projects to open source.
Mhm,
So depending on what project it is and where you are, say if you're at IBM, IBM is known for patenting a lot of stuff, right?
mhm.
They have a huge number of patents, so make more sense to patent some things and open source some others as well.
That's right. Yep.
So we have some questions from the chat from everybody who's been active. I'm gonna start asking those questions.
Sure.
Um, so we have uh, well, this one is partly answered, like you mentioned it later, but Yun Fenglo asked how you generated the quantum self portrait. I know that you mentioned it later on, but maybe you can say a couple more words about it.
Sure. Yeah. So I'll eventually probably do like a thorough write up and hand over like a code base for this one as well. But um, the idea is basically to take a brightness of a pixel channel. So we'll just say like your red is usually between 0 and 255 is just like the arbitrary value that's assigned in like an 8-bit image. It is mapping that to a qubit rotation. So each pixel goes to an individual qubit. And once I've mapped it to a qubit rotation, I can then measure it over and over, and I, in theory, should get a value back that looks relatively similar to the original value that was input. Right now, so in a lot of ways, this is actually more of like a quantum ingestion or image ingestion technique than it is the actual processing of it. But the idea is basically because each individual pixel is an individual qubit, it scales much better. So if I ever run out of qubits, I can just start over and I can continue to draw my image. It also means, though, that it's like once I have a quantum state created from that pixel value, then you could actually do stuff on top of it. That's stuff I don't know yet, right? But there's lots of different work on different types of techniques around what one could do once you have an image encoded into a quantum state. Um, but that's kind of like the short and sweet version. Basically, I'm taking brightness values from pixels and mapping them to quantum rotations.
Okay, nice. So now you can do it yourself, maybe if someone is courageous, you can try to cut it up yourselves. Uh, a question from Show0K: is there a good repository for quantum generated art? So other than my own sites, where should I share mine?
Um, None that I know of, basically. I like maybe the closest answer is like over on the Qiskit Slack workspace. There's a channel in there called Quantum Art. There's people that share a lot of stuff. I really like the idea of like a community around this is still very small. In fact, to whoever asked that, I would if you created something, I would love to know about it. Because it's one of those where there's not a ton of people doing it. I really wish there was a better space for people to get together and share. And currently, the answer is Slack, but I don't know. Hopefully, it'll change in the near future.
Yes. For instance, at QHack, we always have some like artistic related events. So last year we had a t-shirt design competition. This way, we had puzzle designs where you would draw your own puzzles. So it's always good to keep motivated, and there is a space for you, and we have a lot of people uh, showing us and yeah, participating with our own art in different ways.
Hmm.
So I think the community exists. It's just they don't have a place to meet. So
Yeah,
uh,
that's awesome.
for Shul 0K, this is an invitation to help create that space, whether it's Discord, Slack, or somewhere else. Want to create a GitHub repository? That's a good invitation. We have a question from J Teds CC. Which piece of art is your favorite in either the final result or the design process?
So definitely that first image that I showed, the one the called the teleportation disk, for kind of a handful of reasons. So that originally came about with the idea of like I could in theory visualize any quantum circuit. Like I could take the results of any quantum circuit, I can map it against like a noise model, I can extract the data, I can render it however I want. Um, and that felt kind of like an aha moment that was quite nice because suddenly it was like I can make art that's not just by quantum computing, but it's also kind of about it. So it just felt like a good message. And it was this idea that like the mathematics behind or the circuits behind quantum computing, like that's actually kind of the star, right? Where it's like we see lots of images around cryostats and other kind of interesting things, but there's a lot of really just like beautiful math. And so the idea of creating an art piece that really showcases that math was also fairly exciting. Um, and then, of course, I got to make a huge installation out of it and stick it in New York, and so that's also a pretty exciting thing too. So I'm all around quite partial to that project.
Yes, of course. For those who don't know, having an art installation in New York is like some of the greatest achievements you can achieve as an artist. It's a very competitive art space, but very vibrant as well. So getting an
L-
installation in New York is huge.
Literally a dream come true. Yep.
Yes. Um, we have a very interesting question from Yufeng Lo. Uh, this question is, I guess you know DAL E2 from OpenAI. Do you think there's a way to marry that technology with quantum computers too?
So this actually is something I kind of get asked a lot about, like what is the overlap between machine learning or AI art and quantum art? And the short answer is I don't know yet. Like we're kind of talking about two generally disparate versions of emerging technology. I have worked directly with artists to try and answer this, and like it's kind of it's like saying what happens if I were to take watercolor and mix that with ink or pen and ink or something along those lines. Be like, in a lot of ways they're totally separate things, but that doesn't have to be the case. Like if we were to look at both of them as mediums, then it's kind of like up to the artistic interpretation in terms of how the two overlap. um, and but like the skill set required under these two different things, I actually don't know quite as much about Dolly 2 as I should, other than that it's like a text-based engine. um is different, right? So it's like, can we get people who are experts in machine learning and people who are experts in quantum computing or possibly quantum machine learning folks and put them together in a room and say draw something? Like maybe that's a good way to figure it out, but that's totally like a new and ripe area to figure out.
Okay, exciting. New area. We have a question from Quantum Chumba asking, what are you working on next? What's your next project?
Ooh, I've got a good one, but it is a secret, at least for now. Yeah. Well, okay. Actually, I could give you a slightly better answer than that. I do have a good project in mind, and I hope I get to talk about it relatively soon. But it really, this idea of quantum image processing is totally like I need to dig my heels in there. Like, there's just a lot to be done. There's a lot of different ways to go about it. There's a lot of ways to scale it up and make it better than those kind of grainy images currently working on. It's mostly like one of the kind of more interesting things in art is there's only so much that can be done in a vacuum. It really, really helps to have a particular project in mind or a particular like venue and all those kinds of things. So um, for the foreseeable future, I'll be pushing on the quantum image processing technique, and then hopefully in the relatively near future, I'll be able to announce a pretty neat new project.
Okay, nice. So we have Abby UBC telling you this is a very creative talk. So cool.
Okay.
They say, I'm curious about the story and science behind the quantum teleportation art.
Um, Yeah, so that's going back. That's the big disc, the metal one on the wall. Um, it was I think the way it originally started was IBM Quantum wanted to open up a space in Manhattan, and as there were starting to be talks about like how do we really showcase like the fact that this is a quantum specific space for our community and for like the people who work on this stuff. And so we originally started by looking for other artists who could make something that was like a piece about some piece of quantum phenomena. We looked at various different just quantum inspired things. And so I basically made a pitch to some of the executives at IBM Quantum and being like, let me make it. And I will make it not about quantum computing, but I'll make it by quantum computing. And it turns out, I guess that was a pretty strong sell. And so they let me put up the piece. And then we went through various iterations of what is the best quantum algorithm that we should be showcasing in this entrance. And actually, the original one I wanted to do was like the deconstructed circuit for the Toffoli gate, just because like that is such an incredibly important just like thing to be done in quantum computing, but it's also particularly hard to do on hardware, at least today. Um, so we went back and forth in various different ones, but the reason we ultimately settled on the teleportation protocol is because the inventor is Charlie Bennett, or at least he's one of them. And so Charlie Bennett is an IBMer, and there was just kind of like something poetic about being able to showcase the mathematics by somebody who comes from IBM research. And so that's what we ended up going with. Um, it actually took over a year from start to finish. It was like this incredibly massive process, but I guess the rest is history. So.
Well, that's maybe why you ended up having your art installation in New York.
Mhm.
Sometimes these processes take a long time, but they're absolutely worth it. And you
Totally.
have to refine them and change your idea. So you have to be open to new
Mhm.
possibilities. You wanted to do the TOEFL, but actually the teleportation was even better, and
Mhm.
the result speaks on its own.
Mhm.
Um, we have another question by Yung Fang Lo. So their question is, from a designer background slash perspective, how is your experience learning quantum computing slash information? And actually, this probably can be extended even to other backgrounds.
Mhm. Um, it's been really interesting. So I guess it's worth noting that yes, my background is in design and art, but my graduate school work had a pretty heavy like computer science component to it too, which is I think made me kind of like nicely situated to work with emerging technology. So it wasn't totally like I mean the domain of quantum information was absolutely net new, but being able to kind of like take technical and emerging concepts and try and visualize them wasn't necessarily totally new. And so I guess I'm lucky enough to have had kind of like a formalized background in that. Um, but yeah, I don't know. I mean, I think my number one takeaway is like the way that the quantum information gets taught definitely caters to like a particular mindset and a particular background. And I would say in general, I think it's the right approach. But it's one of those where it's like if we do eventually want to get quantum computing out of the lab and out or into the hands of more people than just those who have like a physics background, I think it's important to start thinking about how we teach it, right? To teach it in different ways, because I think teaching to somebody who has an art background is very, very different from teaching to somebody who has a physics background, which is also probably equally as different from somebody who has a computer science background. Um, so yeah, I don't know. It's hard. It is, but it's I quite like it. I'm still fairly enamored with the domain. So.
Yes, it sometimes can feel hard, and coming like seeing people come from different backgrounds, it's amazing that everybody learns in a different way. So I work a lot with educators, and you have to have different tools in your toolkit, right? Maybe you will want to learn through videos or written content or art or
Hmm.
something else. Maybe it's coding challenges. So if you're into this, QHack is your place. Or maybe getting motivated, sometimes a little bit confused too. It's okay if you don't understand everything. Sometimes it sparks the curiosity so that you can dig in deeper.
Hmm.
And acknowledging that, we've had other people coming from a design background. Uh, we had Clem coming the first day talking also about the tools she's making, like through her visual and like design perspective. Um, I think
That's
those
great.
kind of tools are also important for
Totally.
learning and expanding the field.
Hmm.
So everybody keep asking your questions. We have some more time for questions. So we have a question from Christoph Bear. We saw quantum images and quantum music. What about quantum videos?
Yeah. So that's a good one. I like that. Um, in my mind, video is like its own form of medium where it's like where you actually get to use like the elapse of time as a part of like the artistic practice. So it's interesting. When I was doing the quantum design jam with Parsons last year, we did have students that explored quantum information through the lens of animation, and it was cool, right? Like it was definitely one of those where it's like it was the seed of an idea about how they would do it, um, and it's still like an open question to answer because I don't know, in a lot of ways, animation and video is just like a series of sequential still images, but it doesn't have to be that way, right? So I think one of the things I'm curious about is just like the elapse of time over the course of a quantum circuit. Can you use each like layer of a circuit to somehow manipulate a particular frame in a video? And the deeper the circuit, the more noisy it is. So maybe the video has like a descent into chaos or something along those lines. Like, and I've only seen just kind of a tiny bit of people thinking about that. So that's another one where it's like that's totally a great area to start thinking about. So
Yeah. So if you're into videos, that's your space. We have a question from Freemason Magic. I think this is related to the teleportation installation. They said, excellent presentation.
thank you.
Did you actually use IBM quantum processors? The answer is yes, I think, right?
I did.
And
Yep.
the question is, what version? So, what processor did you use?
Falcon R5 was one of our quantum system ones. It was a yeah, it was a 27 qubit Falcon processor. I think I only ended up using 3 qubits off of it to do kind of like the simplest version of quantum teleportation, where the what is generally as a classical register, I ended up using just another qubit, which you can technically do in like a computational aspect. It kind of defeats the purpose, but it is still like a faithful demonstration of quantum teleportation. Um, yeah, I think that's hope that answers the question.
Yeah, I think it does.
Mhm.
Um, okay, here we have a question from Andres Ulid. Um, Hello, your presentation was very good. I
Thank
could
you.
conclude from you that art galleries on quantum topics could have a great future. What do you think?
No, I totally agree. I am in the process of organizing a quantum art exhibition as we speak. Um, so in the very, very near future, that'll definitely be a thing. And I guess it's even worth noting, like, so that person, Roman Lipsky, that artist in Berlin, has already done an exhibition. There's been a couple of other exhibitions from other artists that, like, I don't personally know, so I didn't include them in this talk. So it's one of those where it's starting to come online, right? And I hope sooner than later we'll see more and more of them. And but yeah, it's totally a thing. And hopefully, fingers crossed, I'll be doing an exhibition like next month in New York City uh, on that very subject.
That's awesome. Uh, Later on, you can, if you want to go to the Discord and tell us about that, what is going to happen in 1 month. I think everybody will be happy to hear about that.
Definitely will do.
Um, so, everybody, last couple of minutes, make sure to send your last questions. We have a question from U3HFIW. The question is, part of the reason why I feel quantum behaviors have such allure is that it shows the uncertainty of our physical universe. In terms of using art as a tool to tackle that uncertainty, what can art show us about the quantum process?
Yeah, that's actually a really fun question. Like, I think the way that I sometimes maybe the way that I think about it is like there's kind of like a complete absurdity behind quantum computing in general. Like, it feels like we're tricking the fundamental laws of nature into like doing our math for us or something. And like, I just find that so very interesting. And it's kind of the same idea with art, where it's like who are we to basically be able to take the fundamental laws of nature and like force it to draw pictures for us or something? I don't know. um, but I think there's something fairly compelling about that, where it's just like this is kind of a way of like pulling back the curtain and getting to see like the way our natural world works, right? So on the quantum image processing technique that I'd shown earlier, it was like in a ways that's a way that we can point out some of the flaws in our quantum systems, right? Where we can see the noise. It's kind of a stretch to call those flaws, but like there's something about being able to see it as a part of an image that makes it feel more tangible or makes it feel more like at our level or something, as opposed to just seeing just like calibration data or something. that's kind of like one answer. I think maybe more to your question was like, what can we learn about the quantum world by you doing with art? And like that's I think a fairly open question that is worth exploring more deeply, because it is something. For example, entanglement is so notoriously difficult to properly visualize, and if at all, right? Like if there is a truly good form of visualization for entanglement, I haven't seen it yet. Um, and I don't know, maybe we'll find it by putting kind of our artistic hats on. So I guess we'll see.
And this steps a little bit into the question by Yu Feng Lo. He mentions that quantum art can in some way he asks whether or not quantum art can in some way familiarize people with the unintuitive nature of quantum mechanics. So a little bit connected to this concept of entanglement, and can art help in here?
Yeah. So I really hope so. Right. It's one of those where, like, I think the unintuitive nature of quantum mechanics has to do with how we teach it. It's also like I think the really only true native language of quantum mechanics is math. And the whole like math to art jump is a big one, and that has I think that also has to do with how we teach it. And because I don't know, there are people that just like don't necessarily think mathematically. Is there an intuition that we can still help people build visually? um, and these are like my favorite questions, mostly because they're unanswered. So I really hope so. I really, really hope that we can help people build an intuition for that which is generally considered unintuitive or counterintuitive. Um, but we're definitely at the beginning of that one.
Yep. So we're going with our last question. So I left my favorite question for the end. Um, Abby UBC says, "Awesome story. What would you design if you were to create a piece for Xanadu's headquarters?"
um, that is a great question. I guess maybe we could turn that into a brief and talk about it. No, I'm just kidding. I think part of the hardest and most interesting things to do is have something that is faithful to the math, but also like, or sorry, faithful to the concepts, but also has like some representation of something valuable in the real world. So it's like, what are the core values of Xanadu, and is there something that can be picked up on, that you can actually map back to the quantum phenomenon itself? And like answering those two questions, so frequently like a clear answer arrives, right? And that's like usually the basis for going forward. To give like a less like hand wavy answer, I would say that the Joy Vazirani algorithm I worked with was one that was kind of rooted in typography, and so there's actually a lot that one could do with that algorithm, which is currently open sourced and available on GitHub, and think about that just purely from like the text for the brand of Xanadu. So
Yep. And I guess I'll finish with an invitation. If you want to come to Xanadu headquarters, take a look and think of art. Of course,
mhm.
you're welcome. We're happy to give you a tour of Xanadu headquarters as well.
I'd love that. That'd be very fun. Thank you.
Yes. And also, if you, all of you artists here in the chat, Russell as well, if you want to take a look at the Xanadu art, for every QHack we design new art. So this year it's based on the Bauhaus theme,
Mm.
which is a themed classic like design. And you're gonna see the logo if you go to the QHack website, or even here in the backgrounds that you see in the stream. All this created by a designer based in New York as well. So yeah, really, we are very into art as well.
I love it. That's great.
Yeah. Thank you so much, Russell. We're gonna say goodbye to you, but not to the audience. The people in the audience stay for a giveaway and crucial information for what comes next. But for Russell, however, we are going to say goodbye.
It's been a pleasure. Thanks for having me.